All right, so today we are going to talk about groundwater. So groundwater is water that is under the land surface, and it is often stored in saturated pores of soil or rock. So groundwater is exactly what it says it is. It is underground, right? Groundwater. Then we have what is known as an aquifer. So permeable rock layers are sediments that transmit groundwater freely. Okay, so this is an important source of well water. You don't see a lot of wells down here, but we have a lot of wells up north, especially in the country up north. Then we have porosity. We've seen this word before as well. Okay, porosity, what word do you hear in there? Porosity. A pore, right? And what do pores do? Like the pores on your face, what do they do? Y'all, I know you know this. The pores on your face, what do they do? You go and you take a hot shower, what happens to them? They do what? Open, right? So your pores open and close, so things go in and out of your pore. Okay? So porosity is the percentage of the total volume of rock or sediment that consists of pore spaces. Okay? So you actually saw this in the last unit. This would be low porosity, okay? You don't see a lot of spaces. And this would be high porosity because you see a lot more spaces, okay? That's the difference. So rocks can be sorted either into porous or non-porous. So if they're porous, they are going to have a lot of space. And then if they are non-porous, there's not going to be much space, if any at all. Next is permeability. We've also seen this word. So if we were to pull out a key word here, would be permeable. So this is a material's ability to transmit fluids through interconnected pore spaces. So if we look back at those last picture, the two pictures that were on the board, there are spaces, those pore spaces that can connect to one another, okay? So groundwater can move more slowly when the pore spaces are smaller, okay? Obviously, it will do the opposite if they are larger. So an example of this is fine clay. So fine clay is impermeable because its pore spaces are so small that water cannot move through them. So impermeable means that it's not going to be able to go through. Permeable means that it can go through. And then, when you get into biology, you're going to learn a term called selectively permeable, which describes the cell membrane, and that means that it lets certain things through. Next is the zone of aeration. What word do you hear there? Air. Okay, so this is the region between the Earth's surface and the water table. Okay, I told you we were going to see this word today. So the water table, okay, is the level below which the ground is saturated with water. Below, okay? So a high water table is during periods of heavy rainfall or rapid snowmelt, which can lead to things like flooding. So since the ground is already saturated, which means it's full of water, it can't hold any more, okay? No more water can infiltrate into the ground. So this leads to things like flooding. Okay, we had said that when the water is saturated, it also can lead to things like runoff, okay? But when it is majorly saturated, it will lead to things like flooding. Next is the zone of saturation. And we said saturation means that it is completely what? If it's saturated, it's what? What does it mean? If something is saturated, what does it mean? Y'all just said it. What does it mean? If something is saturated, if you have a sponge and it is saturated with water, what does it mean? Huh? It is wet. But what else does it mean? If it's saturated. If I took a sponge right now and I filled it with water, once it is saturated, it becomes what? Okay, it can, yes. But what is it? The sponge is now what of water? Filled with water, full of water. Yes, thank you. Okay, so it's full. When it's saturated, it's full. And it cannot hold any more. All right. I knew we knew. Okay, so the zone of saturation is the area where water fills all the open spaces in the sediment and rock. Okay, so we find groundwater within this zone. So here is a picture of the water table. Okay, so you can see that below, okay, you have your flow of groundwater, and then up top, which is, sorry, down here, which is your zone of saturation, where the groundwater is. And then up top, you find your zone of aeration, okay? So think air, and we're gonna find air towards the top, okay? Next, we're gonna get into groundwater and surface water and how it interacts through wells, okay? So the first well we are going to talk about is an ordinary well. So this is a hole that's dug below the water table, and it fills with groundwater because we said that the groundwater is in the ground, okay? So for this type of well, pumping is necessary. So several wells are drilled in a given area, and they can deplete the groundwater, okay? Next is what is known as an artesian well. And we need to make sure we understand the difference between these two. So groundwater rises on its own under pressure out of the well. So the pressure is due to the water being sandwiched between two impermeable rocks. So those impermeable rock layers, what does that mean if they're impermeable? Impermeable means what? Okay, it's not going to allow it to go in or go through, okay? So no pumping is necessary. So in an ordinary well, pumping is necessary. In an artesian well, we do not need to pump, okay? Next word is subsidence. Okay, this is the sinking of the Earth's surface in response to geologic or man-induced causes. Man-induced, that means us, okay? So this is caused by pumping water out of the ground. Because if the ground, okay, doesn't have parts of saturation, okay, things like this can happen. Similar to like a sinkhole. So why is subsidence an issue for North Carolina? It can lead to destruction of property, okay, and habits. So like we saw this last time in our last, when we did earthquakes, and we talked about landslides, okay. This is what happens to the roads. Next is springs. Springs are a section of impermeable rock that force groundwater to move laterally, okay, and emerge onto the surface of the earth. So impermeable rock, which means we can or cannot go through. Cannot go through, okay? It forces the groundwater to move laterally and then it emerges onto the surface of the earth. There are what are known as hot springs. Anybody ever heard of a hot spring? Temperatures increase into the earth, so water from the hot springs originate deeper inside the earth, or it can be heated by things like magma, which we talked about when we did volcanoes in the last unit. You ever been to a hot spring? Anybody ever been to a hot spring? Next is what is known as a geyser. Okay, so hot springs that periodically erupt. Sounds kind of like a volcano, huh? Okay, so small openings in the crust, there's pressure that builds until an actual eruption occurs. So in a volcano, what comes out? Okay, so this works in a similar fashion, except what's coming out of a geyser? What do y'all see there? What are we talking about this unit? Water, yes. Sorry, you're so quiet. All right, so a great example of this is Old Faithful in the Yellowstone National Park. All right, and then we're gonna close up with this, and we're gonna get more into pollution this week, but groundwater pollution specifically, okay, groundwater is renewable, yet it is limited. So if something is renewable, that means what? Renewable versus something that's not renewable. Okay, so you can replace it, right? There's more. But if something's non-renewable, you can't replace it, okay? So groundwater is renewable, but we have to keep in mind that it is still limited, okay? So ways that groundwater can be polluted are through fertilizers. Where do fertilizers come into play? What do we use fertilizer for? Okay, so farmers might spray them on their crops, right? Okay, pesticides, same, right? What do pesticides do? What do pesticides do? I know y'all know this. What does a pesticide do? What word do you see in there? What word is in pesticide? A pest. So what does a pesticide do? Nobody. A pesticide keeps pests away. So like insects, bugs, you know, on crops. Yes? Is it ringing a bell now? Yeah? No? All right. Well, you'll see that a little more in biology too. Another one is a sewage system. Yuck, yuck, yuck. Industrial chemicals that might come from big factories. And then also arsenic, which is naturally occurring, can also come from factories. Mining, which is a big thing up north, okay, and preserving bodies, okay? So these are ways that groundwater can be polluted. We'll talk about more pollution later this week, not necessarily specific to groundwater.